not the case. I guess they plowed. There's two different groups. One plows the driveway, and then the other one shovels like the sidewalks and up by the garage. And the plow guy came, but the other people didn't come. So if I could get to my car, I could have backed out. But yep, whatever. It is what it is.
That's why I was wondering why you were looking up when I opened the.
Oh, I have my big monitor up here. I have you guys in a grid up top, and I'm sharing my monitor down below. So I can see more stuff at once, and I can have the chat open and that stuff. But so there's definitely some advantages. Okay. Oh, and I I started I had posted about the live streaming Hearthstone today, and I might still do that. I think that'd be kind of fun. I might even do it in a couple of different sessions today over Zoom and record. But this morning I got up, and while I was stretching, I play in like the kitchen, so I do my stretching in the kitchen and play Hearthstone. So I started the ladder climb because we had the reset yesterday. So I'm typically I have a world ranking, so you'd think I'd be pretty good. I lost like my first 6 games in in like the lowest ranking. I was just getting destroyed. So that would have been pretty funny to
So you're lower than last time we spoke?
well, today, since it's the first of the month, everything resets.
Right.
So you go back to bronze 10, and then you have to reclimb the ladder to get back to legend and then so each month is a season. But I get like a bonus. So I get a bonus to jump up the ranks a little bit quicker. So as I started playing this morning, and maybe sometimes when you first get up, you're a little brain foggy. So maybe you're not thinking as well, but I felt like I was playing competently. But yeah, I just got beat over and over again, but it doesn't hurt me. I didn't fall backwards.
Right.
But it's pretty bad that I have lost 6 games in a row at bronze 10. I think I'm just about to gold now. So maybe I might stream a couple different sessions, and I'm done at 2:00 today. So maybe I'll do something this afternoon and stream it. And you could watch it on YouTube if you're interested later, if you kind of want to see what that looks like. But it would have been pretty funny, I think, if I had been streaming it and just kept losing over and over again, and you guys start berating me. I thought you were supposed to be good at this, and all that stuff. All right, so let me hide that. All right. So last time at the end, we were talking about CPUs, right? I said start here on this slide. Does that look accurate to you? We didn't look at Hello World Linux yet, right?
No, we didn't.
All right. So we had been talking about cost of memory and hard drives and all that stuff. So your paper for today was to look into the actual differences between hard drives and solid state drives, right?
Yes.
Okay. What did we find? Let's give me the highlight reel of what you found in your research.
Well,
a couple things.
Okay, well, speed-wise, flash memory storage are much faster in speeds. I wouldn't just say solid-state drives because there are other types when I did the research. So I'm just gonna generally say flash storage. In terms of speed, they're much faster. In terms of reliability, because of the electric charge and because they don't have moving parts and because they're more durable, so I think they're more reliable. But from what I found out, the HDDs, the mechanical hard drives, have a longer lifespan. than the flash memory storage or the solid state drives, due to the fact that solid state drives use the electric charge to allocate bits, which causes the wear and tear uh, around the mechanical thing. That's why it has, and I wrote that in the paper. That's why it has the wear leveling technique. And I'm sorry if I can't spell that correctly. That's why it has it to, I think to um, equalize the difference. But I found that in the lifespan factor, HDDs have longer lifespan. That's why we use them. I think that's why we use them for larger storage, larger capacity storage, and longer use.
And how much longer lifespan did you find it has?
Well, I didn't compare numbers, but from what I've read in the papers, that seems like it can live long. So I don't think it's a finite lifespan. Sorry, it's infinite lifespan for both. But I think HDDs, from what I've read, is could be higher.
Yeah, so I mean, in general, I would say that solid state drives um, are significantly faster than HDDs, more so than HDDs last longer than solid state drives. So, like you said, HDD probably, pound for pound has a little bit different, little bit longer lifespan. Having said that, and as you pointed out, solid state drives, have some techniques, or driver support for them has some techniques that allows us to prolong the life of them a little bit, to kind of deal with them in the most wear friendly way, kind of like rotating the tires of your car, that type of thing. So every couple thousand miles, 3,000 to 5,000 miles, whatever it is, you rotate your tires so they kind of wear evenly. Kind of a similar idea to that. So I mean, in my mind, and again, I don't necessarily know the exact numbers, but I feel like I would never buy a um, HDD compared to a solid state drive, only for the reason of lifespan. I would think of it more as the application I was using the hard drive for. If I needed just a gigantic storage bucket, I was storing a whole bunch of movies, or I needed scratch space for rendering animations or something like that. In terms of cost effectiveness, a 3 terabyte HDD is going to be more cost effective than I don't know that you can buy those yet in solid state, but if you can, they're going to be pretty pricey. Solid state drives kind of are pretty cost efficient, up to about a terabyte now, and it keeps dropping. A terabyte last year or a year and a half ago was considered probably overpriced. Like you might, if you needed that kind of storage, you might go a different direction. But yeah, it would be more application specific than I think wear and tear specific. Okay, anybody else find anything interesting beyond that?
If I may, uh, I found something else. I found the opposite of what Wally just said. I found that I read that STDs. Many IT professionals agree that HDDs last approximately 3 years or something, and also it is because it might have some physical damage and does not fall proof or shock proof, something like that. And I read that STDs compared to HDDs have a better lifespan because it does something called tunneling. So eventually it might fail, but in general, it lasts longer than HDDs. I read something like that, and I also wrote that in my paper. Yeah,
Yeah, so and really what you're talking about here is as we evolve through some of the technologies, that one of them, so if we go back to day one of solid state drives compared to day one, well, day 4 million of HDDs, which were already around for a long time, you probably did have the reality of a HDD having a longer lifespan, as Wally pointed out. Now, but he also pointed out that there's been these movements towards how do we extend that lifespan. So we're kind of in that cusp right now where, like I said, I probably would never buy a HDD strictly for longer life. There are new technologies coming out pretty often that try to extend the life of a SSD, or through one of the technologies they have. I'm going to talk about one here in a few minutes. But bottom line is I'm not sure that the lifespan difference between them is enough to get too hung up on at this point in time. It's probably, I would say, it's not incorrect to say that one lasts longer than the other, because you could probably make an argument for it. Um, but you could go either direction at this point. I don't think it's a substantial enough difference, but I think the punchline from the conversation here is that at the very least, we want to think about the computer hardware in our system in terms of how long will it last, and wear and tear is a thing, right? Whenever we have moving parts in any sort of system, whether it's your
yeah,
car or a computer, you do want to think about wear and tear. Now, what's interesting about solid state is we actually don't have moving parts in terms of physical moving parts, but the mechanism by which bits are burned is effectively a quote moving part, if you will. So there is wear and tear from it. So it is kind of um, an interesting technology. Okay, so that, I think that's good that presented kind of both of those um, uh, kind of criteria for those. My prediction would be, if we fast forward, I don't know, let's say a year, I think you might be pretty hard pressed to argue that HDDs have longer life. So much of the technology that keeps coming out is a matter of prolonging the life of the solid state drive, so that that's no longer like that discussion. I don't think there's a real strong argument today to get a solid, or to get a HDD over an SSD outside of just cost per gigabyte. If you're just using it for a giant storage bucket, you can get a nice cheap 3 terabyte HDD, and it's going to last you longer than you're probably going to keep the computer, and it's going to be fine. uh, that kind of thing. All right. Anything else that we found that was interesting?
I just want to say one thing that related to HDDs, that I've always found the larger capacity HDDs as, and that's my own opinion, as a single point of failure. I mean, yes, they have a longer lifespan, and we've talked about that. But because they're mechanical, they're prone to, getting damaged, or not being usable at some point. So if I get an 8 terabyte of an HDD, it would be affordable in comparison to an SDD, if I'm just putting it there or storing stuff, as you said, and just leaving it there, no movement, nothing. uh, yeah, but I just wanted to say that I think external HDDs, in particular the portable ones, I think the larger the capacity, the single point of failure they become. I don't
Yeah,
know if that makes sense or not, but
yeah, I think that's reasonable. Um, I think that's probably true of big HDDs as well. Um, so um, maybe that's unrelated to the difference between the technologies. Just whenever you rely on a single storage bucket, you are relying on the reliability. Well, relying on the reliability. You do have a single point of failure, and that's why, like, you guys been messing around with, you and Blade been messing around with, like, Synology with our virtual machine thing, where you have 2, 3, 4 hard drives kind of running together, and it does internally some kind of this RAID network setup, where it tries to spread the read and writes across the hard drives a little bit more, a little bit friendlier, that kind of thing. And if you have one of the drives fail, you swap it out, it can rebuild it, things like that. So we have defense against these different things. So if we're kind of looking for the patterns of what we've been talking about so far today, it's that points of interest when we're selecting a piece of hardware have to do with how long will it last, what happens if it fails, things like that. These are considerations that we make over and above pure speed and capacity. All right, anybody else have anything to add that we didn't really hit?
Hello, sir. Sorry for joining lately.
Oh, no worries.
I have a doubt, small doubt here. So when I was referring to this, when I was trying to look for what are different kinds of flash storages, so, so I saw like array storages, all flash array storages, and specifically in SSD, I saw this single cell and multi cell. I didn't understand that concept in SSD. I didn't what
Okay,
that.
well, yeah, so that has to do with the mechanisms by which it's trying to increase the life of the device, and it also changes the way file systems read and write to it. For us, we don't necessarily care about the direct inner workings of the hard drive itself. That's why today we've kind of been trying to break it into some categories where it's like, make them last longer, make them run faster, give you lots of capacity. The ideal world would be, and also be affordable. So the ideal world will be a gigantic, super fast, long lasting, cheap hard drive. Right? Cheap drive. Let me pop open to this slide. I'm gonna put you guys back up here. Okay, and this might have even been something you saw. I grabbed it off of a web page, but I thought it hit some pretty good kind of the history of these guys. So one of the things that we have been well, talking about a little, if I draw a picture here, let's so we have our motherboard here. And we talked about the motherboard last time as kind of like, we want to think about our computer as like a roadway. Okay, so we have here we can have IO devices underneath here. So our motherboard is kind of like a roadway system where we have some faster roads and some slower roads and some longer roads and some shorter roads, things like that. Now, somewhere we're going to have a hard drive. So this could be an SSD. This could also be a HHD or HDD rather. All right, so these are our competitors we're looking at right here. But these guys plug into our motherboard through some kind of interface. What kind of interface does an HDD use? So when we actually take an HDD and we install it onto our motherboard, how is that connection between the HDD and the motherboard established?
Through bus.
Okay, tell me more. Specifically, how's it established? If you were building this computer, what is the thing that connects the hard drive to the motherboard?
OS, which we install on the hard drive. I mean, I didn't understand exactly what do you mean the interface.
Something connects this guy to this guy. What is it?
It's a serial cable. I just don't remember the name of the.
It's called jumper.
So we got a serial ATA cable, right?
Oh, okay.
So that guy talks through a serial ATA cable. Now, in the early days of solid state drives, we took an improved technology SSD and adapted it to plug into the motherboard through the same interface that already existed. All right. So that's what this is saying here. SSDs have been designed to fit in the same I/O interface as a hard disk drive, such as serial ATA, to connect to the host computer, although most SSDs today use something else, another way of connecting it, like NVMEs. So this is like a fiber channel type thing. So now you have a modern SSD this guy is connecting through, I'm just going to call it fiber for right now. All right, so now you get a newer motherboard. There's a special port on it specifically for connecting NVMe based solid state drives. So now you get a newer, probably faster, blah, 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 probably also more expensive per bit type of solid state drive, which should then give you even more performance and longevity and stuff like that than the early SSDs did compared to an HDD. But it is going to plug into a different kind of port. So now you'll need a motherboard that's compatible with it. All right. So that's kind of our history of these guys from a how does it connect into your motherboard perspective. All right. And then the rest of this you can kind of read through. It gives you a little bit of background, but this is mostly stuff you guys would have looked at in your research. All right. But from our perspective, we're just looking at this is what we used to do. This was the first step of evolution. Faster hard drive, same connection. This is the next step of evolution. Even faster hard drive, but brand new connection that allowed our discussion with that hard drive. Because keep in mind, this guy right here, it doesn't matter how fast or slow that is, the fastest we can talk to it is the speed of this guy. This road that lives between that hard drive and the motherboard. That's the fastest we can talk to it. So if this guy is capable of something faster than this guy, then we're good. But if this guy goes at the, let's say he goes 1,000,000 miles an hour, and this guy can only support 100 miles an hour, the fastest these two will work together is 100 miles per hour. Okay? So the idea here is that serial ATA, there was a 6 gigabit per second serial ATA technology. That is the maximum throughput of using this type of interface between a piece of equipment and the motherboard. All right, so we started hitting that kind of limit, theoretical limit in what our solid state can do. Not that this guy can fully maximize this yet, but we keep moving closer and closer to that. So giving ourselves a larger communication pipeline makes some sense. Okay, so that's kind of our solid state drive discussion. Now, just as a quick reminder, last time we were talking about CPUs. These are the brains of the computer. I like to think of it like a collection of magic tricks. They know how to do a bunch of things. Now, before we look at Hello World Linux, we have not talked about compilers in here yet, have we? Tell me, what's a compiler? So if we write code in C or C++ or Java or C#, we have to compile it before running. What does compiling do? What's that act?
Well, it's basically translating the code that we're writing to low-level language to the computer.
Yep.
Right?
So turns are high level. This is one-to-many relationship with the CPU. Into low level, turns are high level code. Into low level, one-to-one relationship with the CPU, so that it is prepared to run on the CPU. All right, so that is what the job of a compiler does. Why do compilers exist? Ugh. What do you think? What would we do if we didn't have a compiler?
We would have to write the whole machine code.
Okay, pretty close. If we didn't have them, well, let's just go this route. Well, no. If we didn't have them, we would need to write the low-level code, assembly language, ourselves. Why don't we want to do this? So if we didn't have a compiler, if we didn't have that tool that translated from our high-level language to a low-level language, then we'd have to write that that low-level language equivalent ourselves. Why don't we want to do that?
It's a tedious task to write the assembly language.
Okay. Tedious and only cool for 5 minutes before you get frustrated. We like power tools, so we want to use high-level languages. All right, that's our desire as human beings. So we created this idea of a compiler that sits between our high-level language and the actual computer. So we go back to our picture here. Ultimately, let's draw a CPU on here. All right, there's our CPU. All right, so ultimately, this guy receives information. A couple other things out here. They have a monitor. keyboard, mouse. I'm going to keep it fairly simple. All right, so you have those guys. And these guys are I/O devices hooked in through various interfaces, right? So a monitor might have its interface being HDMI. That's hooked into the I/O system. A keyboard and mouse might be USB. All right. Ultimately, these guys go to your through the I/O system. Now, if we're building this up a little bit more, we're going to throw our GPU in here, which then talks to the I/O system, right? So if we're building these sandwiches here, all right. So these are how some of these things are connected to our computer, right? So ultimately, when we're thinking about the CPU, and the CPU's interface is also a I/O thing, usually a big socket that reads things in, writes things out to the CPU, to and from the CPU. All right, so the CPU receives stuff. So we have another guy here, like our RAM, right? So our RAM interfaces with the motherboard through some form of I/O. All right, so it plugs in. There's some little plugs inside your computer where you click the RAM in. If you have like a desktop computer, if you opened up like a newer MacBook or something like that, or you open up a cell phone, as we kind of transition towards this idea of mobile application stuff, you probably wouldn't find a lot of like wires connecting these. You'd find it a lot of solder joints where they actually like melt them together, make them directly attached to each other. So you, because our phones, for example, they keep, even our laptops. So this idea of the mobile world keeps getting smaller and smaller and smaller, which means that we have less space for wires. Fair enough statement. We don't have enough stuff for wires, so we need to have as much of this stuff, these I/O things being direct connections as possible. Okay, makes sense. Now, there's really two rationales. So let's start connecting to the mobile world here, since that's our focus here. There's really two rationales as to why there is these end up being hard-coded interfaces. So we'll say mobile world typically let's see, mobile world typically uses hard-coded interfaces. So using solder instead of a cable, something like that. All right, so these guys are directly melded to this motherboard without there being some sort of wire between them down here. So one reason is, well, So let me ask this question from a mobile perspective. Why are mobile So what are the goals of mobile devices? So when you buy let's kind of focus on like a smartphone. When you buy a smartphone today, what goals do you have for it? What makes one better or worse than another? I'll start you off. Obviously, you care about cost, right? And that's just a human thing, right? So we want the best we can afford. Let's just assume money's no object. What makes one better or worse than another?
Operating system, probably.
Okay, so we might care about OS. So really, this is iOS versus Android. We might make that decision, right? Okay, so certainly that's probably our starting point when we go to buy one. Each of us, we decide, who we love, who we hate, or who we're going to give our money to, and we say what's the best phone in that ecosystem. Okay, so now we've made that decision. Whatever your choice is there, what's next?
Internal storage.
Okay, storage. What do you use the internal storage for on your cell phone?
I mean, nowadays we have basically internal storage for everything instead of using any external storage like memory cards and all.
Yeah, but what are we using it for? So you get your phone, and you're looking at an iPhone, and they have a 32 gig version, a 64 gig version, 128 gig version. What would make you buy one versus another, and why? Is one better than or worse than another?
Maybe offline music and videos.
Okay, more storage equals more photos, videos, apps, etc. All right, it does not make it any faster, right? So more storage is not a speed type thing. It's I can hold more stuff on my device. All right, so if you're somebody who takes a lot of photos, especially today, considering, well, here we'll spin back to it, but well, let's just leave it at this. But if you're going to store a lot of files on your computer, whether on your smartphone, whether it is downloading from the App Store or an image or a video, whatever it is, the more storage you have, the better. Is going to be the idea. One thing you don't want to do, though, is you don't want to, you want to consider how you use your device. So look at your current phone and see how much free storage you have. If you're the type person who's constantly having to delete stuff because you run out of storage on your phone, maybe the next one you should get is a little bit bigger. Then you have the other extreme where you maybe always buy the biggest storage capacity, spending some extra money on that, and you maybe don't come anywhere close to using that storage the way you happen to use your device. And if that's you, then you might be spending an extra $100 or $200 for that phone and getting no additional usability out of it, because probably the rest of it, the guts of the rest of the phone, are the same. All right, what else?
Well, I would say, to be fair, depending on point number 2 on the operating system, if I'm neglecting this point, because this is a big factor, I'd say I'd look at the processor and the RAM and see how well they are in terms of performance on the phone. If I'm gonna use the phone that much. But I'm only saying that because for iOS devices, there's not much to choose from, and as you know, Apple is much more proprietary than Android in their stuff. So I'm not picky when I'm choosing an Apple device. I have choices. It's just not that variant like the Android devices. But In general case, I'd look at the processor and the RAM for the device if I'm picking an Android phone. If I'm a heavy user, if I'm just a random user, I'd probably go for the cost-effective one with a decent processor so it doesn't die from me. That's that's my fair assessment.
Okay, well, but realistically, if we look in there, I mean, let's just abstract what you just said. iOS, well, either one of these, if it's a flagship phone from either of those, it's running the latest CPU. So whatever AX chip from Apple or Snapdragon. On the Android devices in the United States. There's a alternative one they use in other countries, the security thing. But regardless, I mean, effectively what you're doing is you're choosing between Apple's architecture with their the A1, A2, A3 chips, whatever the latest rendition is, and the Snapdragon chip over an Android. Realistically, we can look at the two of these and call them relatively direct competitors, right? Snapdragon has a couple more cores. The AX chips maybe focus a little bit more on per core performance and make some other decisions. But whatever the latest, greatest of each of those is you can assume that that's, you know, a top end CPU, probably less important than choosing the operating system you like. If it's a budget phone, it's running last year's version of the same of the above, something like that, right? That's the reality. If you buy the on sale iPhone, last year's iPhone thing, it's running last year's A chip. If you buy a last year's Samsung or something like that, one of their budgets, running last year's Snapdragon. Both plenty good. For many users, you might not even notice the difference. Depending on how much you care about cost, you might go with this, but it's probably not going to be your deciding factor for which OS you choose. The OS is going to get you started. Maybe, if you think about this again, like in cars, maybe you've just always driven Toyotas. And when you go get your new car, even though you might like the look of a car from Chevy, you might still go in and you're just going to buy a Toyota because that's what you drive Toyotas, and you're going to find what's the best car from Toyota for you. Even though somebody else could argue that, Chevys are better or Chevys are worse or whatever it is. They all have, engines in them with similar size cars, have similar gas mileage, things like that. So somewhere in there just becomes a personal preference type situation, right? Okay, but certainly, I mean, this is an important thing for us to add here because it's very related to this picture we're building up. Where am I at here? Okay. What else? What else do we care about?
Battery life.
Definitely battery life. Okay. And then before we talk more about battery life, let's talk about, let's get the rest of this list up.
Camera specifications.
Good. Camera. Direct relationship with storage needs, right? So I have a Note 10 Ultra. So I mean, here, well, let's use me as part of the example here. Actually, let's finish this, and I want to go through the example that I went through for picking my phone. Okay, so let's just leave camera there, but certainly this is going to have a direct relationship with storage. If I'm taking higher resolution pictures, they're going to require more storage space, which means I'm going to need more storage space if I don't want to run out of memory. I don't want to run out of storage. All right, what else?
Display.
Ooh,
Display.
display.
Screen resolution.
So display size, we might say potentially technology, but frankly, now we've gotten to the point where all the displays are good technology, right? Apple comes out with their latest greatest thing and it's supposed to be better in glare or something like that. And, then, the other guy comes out with something better. So generally speaking, what we're really talking about here today, if we're not, being overly picky, is how big's the display, right? All right. So this guy has a direct relationship with the storage. I'm sorry, with the battery life. Okay. And then we might throw in a very related device size. Direct relationship with the display size and battery life.
Are we considering the tablets into mobile architecture?
Say this again?
Are we considering tablets in these mobile devices?
Sure. I mean, a tablet is effectively a giant phone. Is there something else you are thinking about with tablets that we haven't added to this list?
I mean, I was thinking about like latest Microsoft devices, Neo and Duo. So
Well, right, but is there anything that you're considering for that? I mean, so really you would just, if you wanted to throw, we might say verse Windows 10, for a tablet, something like that.
Yep.
Is there anything else we're really considering here? I mean, you consider the OS, you consider the storage, you consider the battery life, you consider the cameras, you consider the display size.
Processor?
Go ahead.
Processor. A
That's
chip.
right up here. Where do we put the processor? Running the latest CPU.
Okay.
I would consider aesthetics.
Say it one more time.
I would consider the aesthetics of the mobile device. I mean, the way it was built.
Okay, whether it looks cool, the aesthetics. Okay, so we might say how it looks, but realistically, from a technologist perspective, we might say that we care more about all the inner workings and stuff rather than the looks. But if we have two devices that both are very similar specs, we might have the tiebreaker be looks. All right, anything else?
Then what about the build quality?
So let's see, looks, build quality, that kind of stuff. Those all fall into that same category, right? In a situation where you're looking at two very similar devices, you might, in terms of specs, the tiebreaker might be whether one feels like it's a little bit, better built for you. If you drop your phone a lot, you might nudge towards the one that uses the latest, greatest version of Gorilla Glass or something like that. You might like the one that is a certain color, or maybe there's even, some things like you like a specific brand of case or something like that. And that particular brand of case, maybe it's just the right kind of rubbery feeling. It doesn't slide off your dashboard or something like that. And all other things being equal, if you're deciding between two devices and that manufacturer makes a case for one of the devices, maybe you decide, I'm going to go that route. I've had good luck with that case or something like that. Okay, these are more of our tiebreaker-y type of things rather than our computer architecture-y types of things. But that doesn't mean they're unimportant, right? It just means that these are a little bit lower down on the list for our priorities. Okay, anything else we could throw in here? I mean, we got a pretty good list. I mean, this is exactly where I wanted to go with this.
I mean, if we don't consider the smartphones, then I mean, like back in 10 years back, I would consider keyboard as well.
Okay, but even if you do smartphones, I mean, there's people who carry, like for instance, so let's kind of transition towards what I was saying of the decision making for mine. So I run a Samsung Note 10 Ultra. My wife runs the latest iPhone. I write software for both though. So in our household, we have both OSs. I also have a Windows, several Windows-based devices. So I basically have the mobile family for all the different things that you might need. All right. So why did I pick? So if I'm going down here, how important was cost to me? Wasn't important at all. I didn't consider cost at all. I wanted the best phone that money could buy. Now, having said that, cost did come into play a little bit at the very end, and I'll talk about that. All right, for OS, well, I started off on the Android side because my wife already has an iPhone. She likes her iPhone, doesn't like change. I'm relatively happy with Android. If you ask me personally, which ecosystem do I think is the more polished ecosystem, I think iPhone is. I think iPhone has less problems than Android. I have my Android device set up to restart every single night, so I get a nice fresh boot every single day. I never had to do that when I ran iPhone. So even though I think the other OS is the better OS, I'm still choosing Android because it's the more flexible OS for me. And one example, if any of you have ever heard me talk about this, several of you know that my wife and I go on a lot of cruises, right? So we go on a lot of cruise ships. And there is one very interesting software difference between iOS and Android that you might not be aware of. When I say that I'm going to create a hotspot, let me just go here. What is a internet hotspot? What is that guy?
It's turning your phone or smart device into an access point. Something in that familiarity.
So sharing your
Internet connection. Yeah.
phone data plan with, well, let's say
With
sharing
another mobile phone as a
your phone's internet with
oh,
other devices by turning the phone into a Wi-Fi access point. Right? iOS can only share the phone's cellular data plan. In this way. Android can do that, but can also share a connected Wi-Fi connection. What does this mean for me? If I am in the middle of the ocean using the cruise ship's Wi-Fi with an Android device, I can share that Wi-Fi with my laptop and other people without having to buy Wi-Fi for a second device. Cruise ships sell Wi-Fi on a per device basis. So usually we get it for 2 devices. So I have internet, my wife has internet because we're on different parts of the giant boat, right? Well, if I wanted to be on my phone and on my laptop, at the same time, and I was an iPhone user, I would have to either use my wife's device, hopefully she's not on it, or pay for a third device connection, right? With Android, I can connect to the boat's Wi-Fi network, and then I can share that internet connection that my phone's connected to with other people, including my own laptop. Does that make sense? Okay. Have any of you ever been on a cruise before? Never on a cruise?
No.
So what do you think the cost of internet is for a single device for a 1 week cruise? Anybody have a guess?
Is it data constraint or time constraint?
Now it is, well, now it's neither. Most of them are unlimited internet now.
Right.
But for a long time, yeah, a long time I wouldn't even have called it internet on cruise ships. They charged you per minute. It was like, you know, check your email once a day thing to make sure your house is still not on fire, you know, something like that. But now it's, I stream Netflix in the middle of the ocean on cruise ships. So treat it like a cable modem. It's unlimited internet. Royal Caribbean, I would say it's like a cable modem. Some of the other ones, I wouldn't call it quite that quality, but it's certainly as good as like McDonald's Wi-Fi most of the time. All right. So, but what would you guess it costs for unlimited internet for a single device for a week?
I'm thinking of like between $150 to $250 range.
Okay, yeah, that's pretty high. But once upon a time, it probably was that. Let's call it about $60 per device per week, something like that. Okay, so now in an average year, we go on somewhere in the ballpark of, well, I guess it doesn't necessarily matter how many individual cruises we go on. We probably spend about 8 weeks at sea in a given year. So that means cost of internet for Litman per year is 60 times 8, $480 for a single device on a cruise. So what did that mean for me? Choosing Android saved me $480 by only needing a single internet connection on the cruise ship. That's almost the cost of the phone. Now, obviously, this is a very specific example, right? Okay, but this is part of that problem-solving thing. Let me reply to this. Okay. So kind of an interesting thing that you maybe wouldn't have considered was a difference between iOS and Android. Trust me, I've tested it. It's a thing. And frankly, that was the most important difference for me choosing that. Let's go back here. All right. So cost I didn't really consider, but when you take that hotspot thing into consideration, you know, $500 is $500, right? And that almost made the phone, well, not quite free for this one, but you know, significantly less expensive. All right. So that made me go the Android route because of those 8 weeks per year, at the very least, or something like that. But I also then get the benefit if I'm in a place, let's say I'm at the university, and I'm hooked into the Wi-Fi, and somebody is visiting campus who doesn't have a username and password for the better Wi-Fi. I don't have to give them a password or log into their device for them. I can just share my already connected Wi-Fi connection with them, so that they have the better than guest network Wi-Fi for the time period that we're walking around. So lots of little things like that. Anytime I'm at a place that has Wi-Fi that you pay for, or that you need that's secure, having an Android device will let you share that, unless there's some really enterprise level security stuff on there. Then sometimes, like I wonder, it's possible I wouldn't be allowed to share FalconNet on campus. I don't think I've tried, but that is a secure enterprise level connection, and it might prohibit that, but whatever. I think you get the idea. All right. Storage, I have a lot of photos and things like that and apps, but frankly, from the way I use my phone, I probably do not need the maximum storage. I did get the maximum storage because it happened to come with the Ultra version of this phone. So the Ultra version of this phone has some better CPU power, some better cameras, things like this. You get all the extra features, better screen, and it just a better refresh rate, but it just happened to come with a bunch of memory that I likely won't use. All right, battery life. Well, I want to make sure the phone lasts me most of the day. Okay, so I'm not the type of person who sits there and tries to run their phone without charging for 2 or 3 days in a row. As long as I can unplug it during the day, in the morning, have it last most of the day. When I drive and stuff, I usually plug it in. So typically I don't have to I don't run out of battery life during the day, no matter how I use my device. Display size was the biggest deal to me, probably. I watch a lot of videos and things like that on my phone, so I wanted a big display. I also don't have the best eyes, so I wanted to be able to see display, see the display well. Let's see, where else do we have? Camera, yeah, this thing has there's trying to think what the exact number is. It's something like 100+ megapixel camera. One of the cameras on this, I have 3 different cameras on the back of this guy. I don't know if you can see that. 3 different cameras, and one of them is, I don't remember what the exact thing is, but some 100 plus, 108. It's a 108 megapixel camera is what it is. I don't know why I would ever need that. And I don't even know if I've taken, because I'm not a big picture guy. I take pictures like food and stuff like that, not like arty type stuff. But in any case, apparently I have that. Apparently I could take 8K video as well, which I also don't do. But hey, I have it if I want to, something like that. So the camera was not necessarily an important thing to me. It just happened to come with the flagship best screen, blah, blah, blah stuff. All right. I don't really care about the device size because I'm a big person. They all fit in my pocket. Obviously, when I make that decision for a giant display so I can see well, it probably is going to come with a larger device size as well, which is fine. I don't care less about the looks and build quality. I mean, build quality, I guess a little bit. I wouldn't want a phone that I thought was just going to break 2 days into it. But generally, when you're dealing with these flagship phones, which is the ones that I would probably buy, they're all built pretty well. All right, so the way I want about buying my device isn't necessarily the way somebody else would. So this kind of comes back to this idea of, having this technical knowledge so that you don't get taken advantage of it, like a Best Buy or something. Know what you're going to use a device for, and then buy the correct device for the way you're going to use it, given your constraints. All right, makes some sense? All right, so we were talking about So compiler, we want to, humans like power tools. When we write software, we want it at a high level language. The compiler is a tool that a human being wrote that will convert our high level language into low level language so that we don't have to write that low level language directly for the CPU. All right, so it makes our life easier. So I want to, let's see, I want to do compiler. What is a compiler? Let's say, what does a compiler require? All right, so we need a target architecture, which we really care about in here. That's our world in a computer architecture class. Talk about it in a second. And then a target OS. All right. When we say target architecture, can you give me some examples of, well, can you give me an example of a target architecture? I'll take two, but I'll accept one. We've mentioned a couple of them in here. Well, actually, we've indirectly mentioned one of them in here today. So when I talk about architecture, what am I talking about? So maybe that's the easier question to ask at first. So the architecture of a computer is talking about what? What aspect of the computer it reveals the architecture?
The physical aspect or the build.
Okay. I guess tell me more.
Maybe it's a phone or a tablet,
Okay.
different kind of device.
I mean,
Yeah.
it's
Yeah, architecture doesn't speak to that necessarily. What else?
chipset that's been used.
Okay. Tell me more about chipset. What do you mean by chipset?
Like there's a, I mean, the way the chipset is built for Mac and for iOS and Android is different. The way it's working.
Right. Yeah, but you can't define chipset with the word chipset. So
I mean,
when you say chipset, what are you talking about?
The ARM works differently and Snapdragon works differently. So the way it works.
Target architecture is the type of CPU. That is, what language does the CPU speak? i386, ARM. So most mobile devices today use ARM. That's the ultimate language that they're speaking. Now, having said that, Snapdragon, I don't want to lie to you. No, ARM is fine. I can leave it. I can leave it at that. So most mobile devices today use ARM. All right. Now, target OS is the other thing that's required. So what operating system is running on the target architecture? So in our world, this is going to be iOS, Android, Windows 10, something like that.
We still use Java phones, right?
Well, What do you mean? Do we still use Java phones? Tell me, what are you asking? Give me some.
If you don't consider all the smartphone features and all, basically if you are using for communication purpose, then we are still using Java phones. Like the Nokia devices which we have.
Yes, but the operating system for the phone is not written in Java.
Oh, okay. I thought they are written in Java. I mean, Java phones, I thought they are written
Yeah,
in Java.
they are able to run Java programs.
Oh, okay.
Yeah, Ishtiak, the networks that the smartphone can support, T-Mobile, Verizon, things like that. Historically, that maybe would have made a bigger difference, but now you can pretty much get all the phones for any of the major networks. I suppose if you get onto some, very specific network for cost saving or something like that, you might be more limited on the phones you can use. But in general, you can get a Verizon version of any of the phones. Now, to your point, if you're somebody who switches cell phone providers somewhat often, let's say, or you might switch in the near future, you might choose a specific device over another because it's possible you would be able to move that device over to the new carrier without having to like sell the device and getting a new device or something like that. So there are some special situations, but in general, the whoever your cell phone carrier is, you'll be able to get all the devices for that carrier. All right, so when we say target architecture, we're talking about what kind of CPU it's running. Probably an ARM-based CPU. So that's the assembly language. That's the low-level language that the CPU speaks. So this is the low-level language that the CPU speaks. All right, but then we're also looking at the target operating system. Why do we care about this? So ultimately, the compiler we mentioned earlier translates from a high-level language like C or C++ into a low-level language. So let's presume in our example here, it's translating into a low-level assembly language that's understood by an ARM processor. But I'm telling you that a compiler also needs to know what the target operating system is. Why is that? Why do you think a compiler needs to know about the target operating system?
Which programming language is written on it?
No, the programming language has to do with the CPU itself. I mean, when you are using a compiler, the compiler, you're picking the compiler for the language that you want to compile. So you're going to use a C compiler if you're turning C code into a low-level language. You use a Java compiler if you're turning Java code into a low-level language, so on and so forth. But so the compiler we pick, though, it needs to know the target operating system. Why is that? So I used the example earlier that both iOS devices, so iPhones and Android devices, are both using ARM-based processors. But when you use a compiler, when you use Apple's Xcode compiler to turn your Swift code into code that runs natively on the iPhone, it's going to require the knowledge that it's running on iOS. Whereas if you are writing code for Android, it's going to assume you're running on, actually it runs inside of a virtual machine, but let's just make the example strong here. It's going to ultimately have to target the underlying operating system, which is Android. Why is there a difference, even though they're both ultimately ARM processors?
Well, I think since it translates to low-level language to run the program that I wrote, it needs to understand which operating system that it's going to run on to eventually execute the code, I think. Correctly, I mean execute correctly, I mean.
Okay, what does an operating system do? What does an OS do? Okay, you got nothing for me? Oh, come on, you guys know this. You use
Trying.
operating systems all the time. What do
Trying
I?
to understand the
Which
question.
means like operating system is the whole process.
I'm not sure if he finished his answer. You broke up a bunch. Actually, let me just steal this. So the OS sits on top of the hardware, right? And the OS translates for the human. So ultimately, a human being uses an operating system. The operating system then allows us to talk to all that hardware and things like that that make our stuff ultimately run. So when I have a computer program and I compile it, not only do I need to know what that architecture is on the CPU, I also need to know what operating system I'm targeting. Why is that? It's because operating systems, this guy sits between the end user and the hardware and provides a collection of common solutions so that user programs do not need to contain the underlying code to do OS specific tasks. For example, an OS provides a mechanism to write to the screen. To manage memory. Perform IO tasks. With the hard drives. That was called storage medium. Etc. All right, that makes sense. So that's what an operating system does. Homework. Write a 2-page paper explaining why a compiler needs to know about both the target architecture as well as the target OS. That makes sense? All right, I'll put that up on Blackboard and we will meet in person on, well, in person and on Zoom on Wednesday morning. Sound good? I am going to go to chapel on Zoom. So if you want, you can attend chapel on Zoom. It's live streamed. I get to through the portal. So if you were going to come and sit in the front row with me in person, we can sit digitally in the front row on Zoom. All right, I will see everybody on Wednesday.